Hey everybody, thanks again for joining us for another webinar presented by Erlang Solutions. This time we have a special guest host, Bruce Tate, who is back after what I think I can comfortably say was one of our most popular webinars a couple months ago, where he did a live coding demonstration. He's back to do it again with another live coding demonstration, this time focused on GenStateMachines. If you enjoy this and you want to see Bruce talk in New York, he'll be joining us for one of our conferences in New York later this year. There'll be details about that sent in the email. As always, follow us on Twitter, send your questions via the platform. We'd love to hear from you. But without further ado, I will hand over to Bruce, who is going to take you through a live coding demonstration.
Hey folks, it's short story. I was upstairs frantically preparing from this and had just all of the communications off, and my wife sent me this frantic note. Hey, Erlang Solutions is trying to get a hold of you. So no joke, they basically announced these things on Google Calendar because we usually don't have time zone issues, but in this case we did. So if anybody had 13:30 Eastern time for the start of this live cast, I apologize for the problem, and we'll get that taken care of for next time. Hey, I want to announce a couple of things that that you're probably aware of. Of course, I'll be in New York in about a month, and really looking forward. I'm excited to be with you there. There are a couple of other opportunities to see me. I have a conference called Gig City Elixir. That's a great smaller Elixir conference with some really excellent speakers, and that's in Chattanooga, Tennessee, in October 17th through 19th. And I also want to talk to you about one offering that I've got coming up, and this is basically my answer to how would I write more and teach more professionally. And we've come up with a project that's basically subscription based, so that it helps me even out the revenue from writing and kind of know what's coming in from month to month. But the offering is called Programmer Passport. So if you're familiar with 7 languages in 7 weeks, this is our answer to what that should look like in a more modern world, where we'll do we'll just write about individual programming languages, and then we'll also add supplementary video and things like that. Well, without further ado, let's write some code. And most of the time, I try to spend these live coding demonstrations on things that I know pretty well. In this case, I used this as an excuse to learn something new. So we'll see how it goes. The plan right now is to write what I'll call a real-world protocol, and that's the climbers protocol. And kind of implement that 3 ways. Once using a gen server, once using a state machine with function callbacks, and one using a gen state machine with the default callbacks of the handle events. So let's go ahead and start that. So for any of you climbers out there, there's a problem. It's a sport where it's very important to be safe. I mean, nobody wants to hit the ground or see their friends hit the ground. So what we do is we have this safety protocol. So if I'm about to get on a wall, I want to make sure that somebody's looked at my gear and given me the thumbs up. And I also want to be doubly sure that once I start climbing, they are holding on to the safety rope. So the protocol is, I will tell my climbing partner, I'll say, on belay, and they'll respond belay on, right? And then I'll say, and I'm climbing, then I'll say, I'm climbing, and they'll say, climb on, and then I'll go ahead and I'll climb. So you can think about this as a state machine with a couple of different states, right? So I might have, in addition to these, I might also have a ready state. So that's what we're going to build today. And a real world a real world implementation of something like this might come into play if, for example, you had some work that you wanted to do, but you wanted to make sure that all the preconditions were met. So you model this thing in a state machine with a couple of states. You have the ready state, and if it gets the OnBlay message, then it goes to the belay on. And then if it gets from there the climbing message or event, it goes to the climb on state. And then if it gets the climb message, then it actually does some work. So let's go ahead and implement that. So I'm just in a bash terminal shell, and I'm going to type mix new. And I'm going to call this climber. There it is. And for those of you who joined me last time, previously saved. Okay, so I'm going to go ahead and restart that. So make sure I don't have problems with the editor because I can't recover from those, right? So I'm going to go ahead and oh, there we go. So I'm going to go ahead and focus on, so for those of you who joined me last time, we talked about the layers of a typical OTP application, and we remembered it with do fun things with big, loud wildebeest. That's data, functions, tests, boundary, lifecycle, and workers. And we're going to live primarily in the boundary, so I'm not going to split this code up at all. Pretty much all this code is boundary code, so I'll let it live here inside of Climber. So we're actually going to be building a Gen server, and probably a good place to start is in the documentation. So I'll say, I'll start the project in IEX, and now I'm in the IEX shell, and I can use the H function to get some help for the Gen server. And all we're going to do is scroll near the top of this file until we see something that looks familiar that we can use as a template. So here's an example of a stack. So we'll grab that, and that's going to have all the default pieces that we need to implement. So we'll go ahead and replace our climber with this stack, but it's still a climber. And we're going to grab some default state, and we'll go ahead and default to that. Let's call this state. Actually, yeah, that's fine. We'll call it default. And we're going to default that to just an empty map. And but we're actually going to put something in that. We're going to put a state of ready. So we're going to start our state machine in the ready state. And then for init, where is init? So I'm going to drill down till I find init, and I'm going to go ahead to save some space. I'm going to remove these implementations. These implementation tags are because we've implemented a behavior, and so just to save room for the screencast, I'm going to go ahead and remove those. And we're going to implement the init, and basically, this is going to be the state that we're going to keep. And the default state that we'll use is this right here, but we're going to implement that in the start link. So that should be enough. And so the functions that we want to build, we're going to implement these as calls. And the functions are going to be call with an event. And so the events that we have are on, delay, and we expect the server to respond belay on, right? So we'll call this on belay, right? And there's no extra item here. But that's the shape of our general API. So we'll go ahead and delete these things. And now we have to build out the implementation for OnBlay. So we look for the first call, which is pop. And so this is OnBlay. We don't care who the message is from. We're going to let Erlang, which is behind Elixir, solve that for us. And this is the state. So we're going to reply, belay is on. And we're going to do a map put. We're going to add to the state the key value pair of state, and we're going to add ready. So it's going to move us from OnBlay. If it's going to move us from ready, if I'm asking if I'm on belay, I'll say yes, belay is on. Okay, I hope we're doing okay with the font size there. So that's generally how this will work. So let's go ahead and try out what we have. Right, and I should be able to say, I always forget that part. I'm kind of thrilled that I got it. And we'll do the climber, and the functions that I can choose from are those, and I basically want to do a start link, right? So now I could say climber on belay, and it needs a PID, and I get back belay is on. So we're already tracking our implementation well. So I'll go ahead and implement the next piece, which is the, so if from the ready state, I can issue on belay. For the belay on state, I can issue the climbing, right? And this is the, so we'll build one of these, copy that much. So this is climbing. And instead of belay on, I'm going to issue it, or instead of belay on, I'll pick this up in both places. We'll do a climb on. Okay, so let's recompile. Okay. And we started up on belay. And now I should be able to say climbing. And sure enough, I'm climbing. So we're working out pretty well. So you can see that there's quite a bit of ceremony here for a lot of repeated work. But let's go ahead and flesh out the rest of this implementation. So the next piece is where I'm actually going to do the work. And so I can't jump in here and climb, but I can call a function. So instead of just a PID, I'm going to take a function which is going to represent the work that I'm going to do for the climber. And so I'll do a call, and rather than just climb, I'll send a tuple with climb and my function. And so to handle the call here, I'll go ahead and, so this is a tuple now. And the function, and I actually have to do that work now. And so if I'm in the state climb on, I want to go back to the state ready, right? But I actually want to fire this to do the work. Now, I'd like some feedback to know what's happening here. Whether I keep it in here, it doesn't matter. But let's just go ahead and add some feedback. And so I'll say io.puts and some kind of message. And up here, I'll say, so I've got you. So you're on belay. I can see your gear and it works. For the climbing, I say, go for it. And then for the climb, I could say, be careful. Until this point, this has been a pretty realistic talk. You would never see an experienced climber say that. Our mothers say that. instead, so when we're done, let's say, and jump back into realism. So let's see what happens here. So basically what I'm expecting is that I'll go from a start link, which is the ready state. And then if I ask OnBlay, I'll transition to a belay on state. And if I go to climbing, I'll transition to a climb on state. And if I climb from a climb on state, then it will basically fire my function and I'm in good shape. So let's see if the happy path works. So recompile. So I'm going to start this thing, and now I'm going to say on belay. Yep, belay is on. Climbing. Yep. And so now I can say climb, and I can take a PID, and it also takes a function, but this function is going to be io.puts. I really like to climb. And do we need, yeah, that looks good. Oh, okay. So then I got the feedback. Hey, be careful. The only unrealistic part of this, and I'm climbing, and great climb. So we could see that it did the work successfully. Okay, and so we're back in ready state. Now the problem is that I am letting some interactions happen that shouldn't actually happen. For example, I'm in the ready state now, and I should not let someone climb because I have not verified that their gear is okay and that somebody's holding on to the rope. But look at that. It's got no such verification. So that's the next piece of our job. So now what we'll do is we'll basically pattern match on these states and make sure we get the right state. Right? And so for this one, this happens if I'm in the ready state. And this one happens if I'm in the belay on. So my gear has been checked. This keeps getting smaller. So by the time that this talk is over, it'll be microscopic. And this should be from the climb on state, right? So if I'm in the climb on state, if my belay's on, I'm okay to start to ask about the climbing. And if I'm in the climb on state, it should be okay for me to climb. So that's how to read that. So now let's recompile. All right, now on belay. Now if I do an on belay again, I get a crash, which maybe is exactly the behavior that we want. We might want to add another callback here, a handle call for events where I'm not in the state that I expect. And maybe that sets me to some type of an error state. Maybe that notifies folks that we're going back to the ready state or something of that nature. But so this program isn't, so I'm not talking about how to basically handle the protocol. I'm talking about how to implement the protocol so that I could take action. Okay, so that's the first of 3 ways. Now, you can imagine that this would be a lot of ceremony for this small amount of code, especially in another process. So there's a hex dependency that we can add that can simplify this work for us, and it's called GenStateMachine. And so I'm going to create a dependency that looks like this. And this is GenStateMachine. And a state machine is just something that has nodes and events between them. And events cause a movement potentially from one node to another. And I happen to know that the latest version is 205. But if I didn't, I could do something like this. Right? I could save it, and then I could do a mix_deps.get. Oh, that's too big. Let's grab the latest version here. So we'll drop that in there, and that looks good. Now maybe we want to grab the latest from 2.0, but we'll just go ahead and grab the latest. And we'll do a mixeddeps.get again. So now it's retrieved my dependency and we're ready to go. So we should see a GenStateMachine, and we do. And this is the one that we want to use. There's another one, GenFSM or something like that. So on GenFS, so we're going to basically look at this one, and we're going to grab a couple of implementations out of here. You can see there's a lot of data, probably more than we can handle. But there are a couple of patterns that we could base our implementation off of. One is a switch, which implements a simple on-off switch. So calling flip from off turns it on, calling flip from on turns it off. So just to kind of keep track, let's create a new browser tab and drop this in here. And while we're here, let's create a new browser tab. And so I told you we were going to implement two different implementations. One of them is this one. This is with state functions. This is a lightweight one. But then there's also the bare metal version, and that's the handle event or the event callback. And basically it looks like this. And all we're doing is we're setting the callback mode, which is either functions or a handle event callback. And since the default is the event functions, you know, we won't see that specified in this implementation, right? So there's no, this basically is the same as callback functions of, I don't know, I think they're called the handle event events or something like that. So we're going to implement this. So let's get a lay of the land. We can see that that there are a couple of different implementations of off. So basically, off and on are states in our state machine. So our functions should say ready, belay on, and climb on, because those are the states in our state machine. You can also notice that they're using cast rather than our call. So maybe we want to change that, but if we do, it'll add a lot of boilerplate, so we may as well flip over to the other model of handling callbacks. So we'll go ahead and implement this as a cast. And you can see that we don't yet have a way to, that there's no way to add a function. So we'll have to implement ours in a tuple, but we can do that. So let's go ahead and grab this much. Okay. And we'll go ahead and just replace everything that we have in the climber. So notice before we were using Gen server, we're using a different behavior now. We're using the GenStateMachine and we're using the state functions. And that means rather than off, we'll have, let's go ahead and delete this one. I would use this one if I had as a catch-all. So if I had some events coming into the off that, that weren't handled in the event list here. So let's talk about, so since these are states, our first state is ready. So we're going to call a cast from ready. And so the message that we can take from ready is on belay. Right? Now I'm going to get some data, whatever data I put in the state machine, but I'm going to initialize our first data to nil. We're actually not going to use the data at all. In fact, this implementation was using it just to count a number of clicks on the switch, right? So the next thing that I have to do is I have to set the next stage in the state machine. actually, let's just take the data and just pair it back whatever's in the data. And so our next state, so if I'm on OnBlay, or if I'm in ready and I get an OnBlay event, my next state is belay is on. Okay, so we should be able to try that. So that's a lot less boilerplate ceremony, whatever you want to call it. And so now we can recompile. It looks like everything is working. And now we can look at our usage model, which we moved over to the browser. And you can see that we start with basically the same approach. You see a couple of things that we're going to have to change here. We're working on our climber class, and our initial state will be ready, and our initial data could be anything. Since we're not really using it, we're just passing it on through. We can call it nil, or we could call it something like unused. So let's go ahead and do that. Let's start. We have an initial, so we're going to use a climber, and this is the ready, and we're going to say unused. Right? Okay, so this is the data behind our state machine. This is our state, and this is any kind of user data. If you want something richer, you could throw a map or a list in there, and that'll be fine. Okay, but now I can start to use this thing, and the usage model looks like this. So I'm going to call a simple GenStateMachine cast to whatever PID, right? So that looks like this. I'm going to cast, and so we're going to cast on belay. And so it casts the on belay. And we don't get a response back. All we know is that the cast worked. If we want some feedback, and we probably do, the way to do it, so if we're not using the full event callbacks, the way to do it is probably from a debug perspective, the same way that we did before. So, gotcha, right? So we'll recompile. Okay, so this is looking good. This is looking like this implementation will go quickly. So if we're in the ready state, we do that. So now we need a couple more of these. So if I am in the belay on state, and if I cast then to climbing, so remember, this is the event, or this is the state, and this is the event. So I'm going to say, go for it, you're climbing. I'm going to go ahead and just return whatever data, and I'll say climb on. The next state is climb on. So we should be happy there. So the next one, if I'm in the climb on state, and I get a climb message, that's not enough for me. I also need to track my function. Oh, did I do this wrong? I did. So I cast, and the message is climb. There we go. So some people were looking at me strangely through the internet, and I could feel it. So I'm going to say starting have a nice climb. Great climb. And then I can call the function just like that. And the next state, we're going to flip this to ready. We're just going to pass the data on through. Okay, so now we ought to be able to so we're casting the on belay. We're going to cast a climbing, go for it. And now we're going to cast the climb, but we need a function to actually do some work. Right, and so our function is going to say something like, very high up here. Okay. Okay. So I got to have a nice climb. It's high, great climb. So we're looking good. So I want to make sure that this process is not the one that's actually doing the work. So let's just make good and sure about that. Okay, and so self is a process ID of where this code is running, right? So I'm gonna OnBlay, I'm climbing. Okay, and now I'm doing that work. Okay, what happened here? Chartman, okay, we know how to fix that. I just need to inspect this. So basically what happened here is this error, this means that I tried to convert that to characters and it wasn't able to, but it's all good. OnBlay. Oh, I didn't start. I'm climbing. Okay, so this is the process that's doing the climbing, and it's not the same process that this one is in. Okay, so right now we're working relatively well for our happy path, but this gen server is not giving us any protection. Or wait a minute, this gen server is giving us protection because we are enforcing the state that we came from. So I can only get the OnBlay message from the ready. So if I try to climb again, then it's going to crash exactly like we hope it will. And if we want to catch that error, all I have to do is drop in another handle event message. So this way to build state machines is okay, but you lose a lot of flexibility. So what I'd like to do instead is build in this alternate model. So this is the same implementation for the switch. And in this case, you can see that we're still in the GenStateMachine. And let's go ahead and set this to Elixir. We can still see that we're in the same state machine, but we're not using the callback models that we saw in this one of state functions. We're not seeing the callback mode of this one. So let's go ahead and grab this implementation and see what that, actually we don't need the mix console, but we'll leave that around so that when it's time to test things that we can. And I'll show you a couple of features that will allow us to stretch this implementation. So this is the climber, right? We're using GenStateMachine. And we're going to use, in this case, call events, but the calls take a different shape. And, well, actually, we have one here. Let's pattern our implementation after this one. So so if I am in the let's go ahead and expand this out. So if I'm in the, if I get the OnBlay from a state of okay. So from a state of ready, remember the state machine is going to break out these pieces for us. So if I get an OnBlay, I'm going to go ahead and expand or shorten this up again. If I get an OnBlay and I'm in the ready state and I get some data through, what I want to do is say the next state is belay on. I want you to pass the same data through, and I want you to reply to from with whatever data that we've got, right? And yeah, so this should give me a very similar implementation. And let's go ahead and grab the start link and just make it a little bit easier on ourselves. So if you pass me some data, I'm okay, but I'm going to default that to, right? Then I'm going to do this work, and I'm going to say, so okay, PID is that thing, and this is a climber. And I'm going to start this in the ready state, and let's just call this state like that. Just so I don't shrink the, so the people with less of a screen situation can handle it. So now we have a start link, and that'll work. And now we have an OnBlay. It should be very quick to change this to implement our state machine. So if I get a handle event from, if I get a handle event of climbing from the belay on state, that's okay. So I want to do this work. Climb on. And let's do this. Let's respond. So we're sending a reply to from a belay on. So let's actually send the results back to whoever's requesting. I think that'll be a more pleasing API. So let's grab one more of these. Now, if I get a call, it's coming from, and if this is the climb, remember that's not enough. This needs to be a tuple that also has a function. If this is to climb with some data, we're actually going to transition. The next data is going to be ready, and we're going to respond with the result of our function. Okay, so let's go ahead and try this much out. Okay, PID is unused, so that doesn't strike me as good news, but let's see. I bet we have a bug in there. We do. So we'd actually like this to return PID, right? Let's do a PID is equal to climber.startLink. Oh. Try that again. There we go. So now we have a PID. We've saved ourselves a little bit of work. Actually, that's probably not a good idea. We're going to go ahead and we don't want to change the semantics of this function. So that'll bite us later when we're working on infrastructure and kind of the life cycle and things like that. So now I have a PID, and I could say climber, or I could say GenStateMachine.cast, and I can cast to PID. No, I'm going to call. I can call to PID, and then I want to specify a message, and in this case is OnBlay. I get back a belay on, and I want to do a climbing, and I get a climb on, and now I could say climb, and with my function, so I'm down safe and sound. Again, this is completely unrealistic unless I'm climbing with my mother. Oh, what's happening here? We're getting a no function and clause handle event. Let's see what we got here. We got a call, a PID, and the from, and then we got the climb function. Climb on unread. Oh, I bet I know the problem. Yeah, this is the problem right here. So I actually, let's catch back up. Thought I knew the problem. Okay, so let's look at our API again. So we're going to GenStateMachine of call of PID. So that shape looks good to me. Let's see the message that we got. So we're getting the message, no function clause matching in climber handle event. Okay, so climb on unused. So I bet that we didn't pick up that, yeah, here we go. So we're getting the climb, but the state, this is going to break unless I'm in the climb state, but I'm not in the climb state, I'm in the climb on state. So again, these are the states that I expect. So we compile 1, 2, 3, 4. So I'm going to call the state link. I'm on belay. I'm climbing. And then I'm going to do I'm going to call with, and then the function, I'm going to I'm going for it. And then I got returned. I'm going for it, so that means that our function got called. So this is a great start to our safety protocol. I'd like to do one more thing though. One of the things that would be nice to do is to establish a timeout so that you know, in the real world, the are you on belay question and my belay is on has it has a real world timeout, right? So if you say I'm climbing and then you hear a response climb on, that is not good for days at a time, right? Somebody could walk away, any number of things can happen. So if this is some type of time sensitive safety feature, we want to allow for the possibility that we're in a state, we've kind of been left in a state awaiting an event for safety, and that event hasn't happened, that message hasn't happened like we expected to. So the way to solve this is with a timeout. And the best way to do this is with a response that looks like this, right? So in this case, I'm sending back a next state tuple. But what I want you to watch, these are the actions, and you've already seen this one. This says reply to from with climb on. But in this case, what I'd like to do is add a timeout. And this timeout says, if you hit a state timeout of 10,000, I want you to essentially time out and pass this data. Okay. So let's go ahead and implement that. And the implementation looks like this. Let's grab the implementation, and later we will come back and we will grab the other piece. So this is the implementation. So I'm getting a state timeout, and let's kind of look at the shape of these handle events. And so I'm getting the data. I'm getting the state timeout. I'm getting the data ready. This is the state that I'm in. I don't care if I get a timeout. I basically am going to do the same thing. If I'm getting data, then this is what I want to do. So let's go ahead and echo this. So my next state, I want to be ready, and I'm going to pass whatever the data is on through. And in this case, I'm going to reply to from with ready. Okay. And so now I have the new event in place, and now all I have to do is change the shape of these functions to allow for the extra data. So my next state is that, and let's say we're going to indent the data, put that at the same indentation, and let's go ahead and put this at the same indentation. And we're going to add to this tuple. So these are the actions that are coming back. And what I want to do is I want to add a state of maybe 10 seconds. And maybe I want to send back a ready. So that's the state I want to take them to. I'll close that. I want to close that. I think that looks good. Let's see. Usually with that much multi-cursor, I'm messing with myself a little bit, but I think this is going to be okay. So let's see. Okay, so okay, let's see. Undefined function from. Okay, so that's on line 46. Actually, I don't need to do that because my reply, yeah, since this is basically going to be cast anyway, since it's a timeout. So all I really need to do is set my next state. Okay, let's try that. We're okay. So now, belay, climbing, and so for 5, 6, 7, 8, 9, 10. Okay, so in theory, if I try to climb from here, it should give me an error because I should have timed out. And in fact, I do get the error. So if we want to see this timeout in action, we know where to write the code. Let's go ahead and do that. reporting due to inactivity. Okay, so let's recompile. We're starting up. We're on belay. We're climbing. About now, we should see an error message that tells me that I'm timing out. There it is. And now I can start the flow over again. And I'm good. So that's all the work that we want to do in this state machine. What I want to sum up is that we have used a state machine to implement a real world protocol. And this is incredibly useful for areas where we want to basically put some type of a guard situation around work that's particularly dangerous, or work that we need to time out. And this also works with any kind of state machine that you have. If you have a simple flow, then you might check out the callback functions instead. If you have a more complex one, you probably want the handle events. And with that, I'm ready to take some questions.
Hey, Bruce, thanks again for another fantastic presentation. I think I speak for everyone when I said that was really insightful and really helpful. We've only had the one question through so far, so if you do have a question for Bruce, please do submit them while he's taking the first answer. The question here that we did get through was that you mentioned the GenFSM server as well. What is the difference between the two, and where would you use one and not the other?
So I'm kind of new to this. I know that the GenFSM is deprecated, and so I'm focusing on this implementation.
Perfect. Perfect. Just quickly scrolling around to make sure we haven't had another question coming through. No, so that's it for that today. I guess,
so if I could, can I remind people that we have the conferences coming up? You have your chance to join Erlang Solutions and I in New York. That should be excellent. Then 1 month later, we have, or actually not even that far later, a couple of weeks later, you have an opportunity to see Gig City Elixir. And we've got Dave Thomas and Justin Snett coming, and myself, and we have a pretty fantastic lineup for that as well. And the last opportunity I'd love for you to take advantage of is this kind of new publishing model with the Pragmatic Bookshelf, and we're announcing the Programmer Passport, and that will launch this month on the 16th, and we'd love to join you with the Crystal language, and then the community votes on the next few languages that we'll do.
Perfect. We have just had a few last-minute questions come through, Bruce. Would you be kind enough to take them?
Absolutely.
Cool. So we had somebody say that they loved the timeout feature. Do you have any recommendations on how to deal with more complex state machines? For example, they're working on a multiplayer card game and have many state machines in there, like the seedings on a table, status of the game, hands of the player, and those are all connected with each other. Sometimes they're struggling to think through this. Do you have any tips for how you would solve that problem?
Yeah, so basically I think of it, I try to stand that question on its head. So if the problem that I am solving lends itself well to a state machine, then basically the questions become mechanical ones, right? And the transitions between the states become pretty straightforward. The timeouts become, the timeouts become a way to implement a system generated event. So I think that the question, how do you deal with complicated state machines? That's really the question that you should be asking is, does the problem that I'm solving lend itself well to state machines? And if it is, this is a way to implement them, and think of a timeout as just a state machine or a system generated event. So I know that's kind of a roundabout answer, but that's the best I can do with that one.
No, that's perfect. And then the last one we had is, how would we handle a sensor, for example, that is telling us the path is clear, or any other situation where the variable may oscillate due to wind or other uncontrolled circumstances?
Yeah, so the sensor one is actually a pretty good one for a state machine, right? So yeah. You could have, for example, quite often with nerves type implementations, there are green states and red states. Green states where the state says, "Hey, you're clear to go." There might be a yellow state that says, "Hey, we've had a glitch. It doesn't. This sensor has tripped, but we're not confident that it's that in our input." And then the red state is this sensor has repeatedly tripped, and we know that that's a bad state. So what I would suggest is look at your business problem and see if the business problem lends itself to more than just two states, go or no go. And the second piece of advice is look at your business problem and see if and try to think of how you would handle non-response, right? So non-response might not matter in the case of like a weather station. Non-response would be a big deal in the case of something, for example, looking at runways, to reroute, to potentially send suggestions to air traffic control to reroute traffic.
Perfect. And final one, for a complex system, are there alternatives to state machines that you would consider?
Yes. So basically, a great example of a complex system that we would consider where a state machine didn't work as well. Check out designing Elixir systems with OTP. We actually build a kind of an implementation of a quiz, and so we call that implementation mastery. And the mastery, it has some state machine types of interactions, but we weren't able to fit that problem cleanly into a state machine. So yeah, check that one out. But yeah, so a state machine is a tool. It's not a golden hammer. If the problem doesn't feel like it fits into the state machine, definitely don't try to use it.
Perfect. And for that last example, I will, for everybody listening who wants more information, I will get a link to the book that Bruce was talking about, and I'll include that into the email I send around in the week following, along with the recording of this.
If you want to test your luck, there's an Elixir conference code for 20% off. It might still be active. I don't know if it was a week, but the code is camelcase ElixirConf _2019 _ all uppercase OTP.
Perfect. Cool. Yeah, that is the last of the questions. Thank you, Bruce, for joining us. Thank you, everybody who's been following along. As always, we will send a recording of this along with links to the conferences that Bruce has talked about earlier today, and more information on Programmer Passport. That'll all be in the email that comes out to you next week. So do make sure you check your inbox for something from us. Until next time, thank you. Thanks, Bruce.
You're quite welcome.